Mrs. Young, and this video is on Lesson 6, Analyzing Functions and Their Graphs. Remember, anytime you're watching a video, you can pause it, rewind it, or even rewatch it. There is no need for a calculator today, and I am not going to have a bell ringer for today. So go ahead and open your packet up to page 30. Again, if you don't have your packet, it is in the Google Classroom. You can print it out, or you can just write this out on paper or scratch paper of your own. So again, we're on page 30 of the functions packet. Analyzing functions and graphs. So it says here we can analyze parts of a function by describing them as increasing or decreasing. I always think of slope dude, right? So increasing is when the graph goes uphill, and decreasing is when the graph goes downhill. We can also describe graphs as being linear. Linear has the root word line in it. Linear means straight line. Or we can describe them as being nonlinear. And we did talk about nonlinear graphs earlier in this packet. Nonlinear, remember, it's not a straight line, so we saw some curved graphs or some crazy graphs that are nonlinear. Describe the parts of the function shown below. So we see this graph down below, this curved line, right? So that's our graph that we're looking at. And over here in part A, it says between x is 0 and x is 4. So here is my x-axis. Here is where 0 is. And then here is where 4 is. Sorry, there's where 4 is. So we want to look at the graph between those 2 points. So we can see that the graph right here, between 0 and 4, what's happening? Well, it's going uphill, so it's increasing. And there is, hopefully you notice, there's a slight curve to it, so it is nonlinear. So it is increasing and nonlinear between x is 0 and x is 4. So we're just looking at that section of the graph, right, between those two x values, 0 and 4. The second part here says between x is 4 and x is 8. So here's where x is 4, right? You see where that is. And then here's where x is 8. So between those 2 points, what's happening to my graph? What's happening to that line? Well, it's going downhill, so it is decreasing. And again, it's kind of curved. It's not a perfectly straight line, so we say it is nonlinear. So decreasing, nonlinear between x is 4 and x is 8. So again, graphs or functions are either increasing or decreasing, going uphill or downhill, and then either linear or nonlinear, straight lines or curved lines. A distance versus time graph shows us how far two objects are from one another. Consider what the following types of lines on a distance versus time graph would represent. Again, here's my distance over time. So over time here, we're starting at the origin, right? And we're steadily increasing our distance. So you're moving away, but because it's a straight line, you're moving at a constant speed or constant rate. So we can say here that we are moving away because we are increasing our distance. Our distance is going up, and we're moving at a constant speed or rate. Right? They're consistently moving the same pace. That's why the distance is going up at the same amount each time. It's a straight line, has a constant slope or rate of change. In my second one here, B, we can see the line starts up here and it's going downhill. So now your distance is going down or decreasing, so we can say that we're moving closer to the object or the item. We're moving closer, let's say, to home or wherever you're trying to go. But again, it's a straight line, so we're still moving at that constant speed or rate because it's a straight line. You're still moving at a constant speed or rate. And then the third one there, in letter C, we can see that the line is a straight horizontal line, so your distance is not changing over time. So if your distance isn't changing over time, that means that an object or person or thing or whatever is at rest or not moving. So again, not moving or at rest if we have that constant distance. The distance is not changing. Down here in letter D, in letter D, I can see that, sure, my line is going up, it's increasing, but this time it's curved, it's not linear. So in this one, we are moving away again, just like in A, we're moving away because our distance is going up. We're moving further away from something, but we're moving at an increasing speed or increasing rate. So they're going faster and faster as they go. Right? So again, we're moving away at an increasing rate or speed. And then finally, that last one there in E, again, we can see that we're moving away, but this time we're gradually decreasing our speed. Right? So again, this one is moving away because it's going uphill, but we're gradually slowing down. It's like when you're in a car and you slow down and stop, right? So their speed is decreasing. So we're going to say decreasing rate or speed. Okay, so make sure you have everything copied down on that page. And then when you're ready, on page 30, and when you're ready, go ahead and turn over to page 31. Okay, so here on page 31, it says match each distance versus time graph with the correct description. So then look at your graphs first. The first one on the left, it's going up, then it's flat, then it goes up again. But again, notice when it's increasing or going up, it's going at a constant rate. In the second one, it goes up, it's flat, it goes up, it's flat, and then it goes up a third time. And then the last one goes up, it's flat for a little bit, but then comes back on the distance, so moving closer, little flat piece down there, and then it goes back up. So we have to match those to A, B, and C. So let's read the description. Kaylee got on the bus at her house. The bus made 2 more stops before it arrived at school. So we've got Kaylee's stop and then 2 more stops, right? So Kaylee got on the bus. It made a stop here. It moved again, and then made another stop for another group of kids, and then kept going before it arrived at school. So I'm going to say that has to match up with A. Again, the key there is that it made 2 stops, and the stops are the flat parts, because that's when your distance is not changing. So I'm going to choose description A for the graph in the middle. Now let's read letter B. Brennan and his dad left for school in his dad's car. So they're going to be moving away. They stopped at the train tracks for several minutes before they were able to continue. So again, if you're stopping for several minutes, we're going to see a good flat section there in your graph, and then again continued on to school. So to me that looks like the first graph. Here they left for school, they're driving away from their house. They stop for a good amount of time where the train goes through, and then they continue on to school. So I would choose description B for the graph on the left. And then finally, Cameron left for school with his mom, but he remembered that he left his English project at home. So here he goes away from home, but then he has to go back to get his project. There's a little flat piece here, probably where he's in the house getting his project, and then heads back to school without any stops. So again, left for school, paused, turned around, went back home, and in the house got his stuff, and then went back to school. So I'm going to choose description C for the graph on the right. So again, matching up the description or descriptors with the graphs. Number 2, create a distance versus time graph showing Adam's distance from his house. Label each segment of the graph. So we have Adam left his friend Brody's house and started walking home. Adam realized he left his phone at Brody's, so he turned around to get it. Adam left Brody's a second time and started to walk home. Adam stopped halfway to talk to a friend he passed, and then he quickly ran home to make it in time for dinner. So again, we're assuming that this is our house, and he's starting at a friend's house, so he's starting a certain distance away from home to begin with. So thinking of the part A of the description, It says Adam left his friend Brody's house and started walking home. So I'm going to put a dot somewhere up here. Here he is at his friend Brody's house, and his distance is going to go closer to his house. So this part of the line is going to go downhill. So that's the part A of this, right? So that's the A section of my graph. And then B, Adam realized he left his phone at Brody's house, so he turned around to get it. So he, again, turned around and went back to Brody's house. So we're going to see the line go back up here, right? So that's B. He went back to his friend's Brody's house. The other thing that I probably should be doing here, I just thought of this, I probably should be labeling the sections of my graph as they match up to the descriptions. So this section of the graph is A, and then this section of the graph is B. And then for C, it says Adam left Brody's a second time and started to walk home. But then I see in D, he's going to stop halfway to talk to a friend he passed. So again, here's Brody's house. Here's his house. He's going to be stopping halfway. I'm thinking about where halfway is going to be on my graph. So he's going to be walking home and stopping kind of at the halfway point. So here he is walking to his house. That's going to be letter C of our description. And then it says here in D, Adam stopped halfway to talk to a friend he passed. So he's going to have a flat piece here because he stopped for a while. So we're going to draw a little flat piece to our graph. Again, that's section D, where he's stopping and talking to a friend. And then finally it says he quickly ran home to make it in time for dinner. So, you know, here we're walking. So if you're going to run, you're probably going faster. So the faster speed or rate is going to give us a bigger slope. So it's going to be a steeper line. So this last part, I'm going to make it kind of steep, and that's going to be letter E. That's the part where he ran home to make it in time for dinner. You can even see here that we're kind of dividing up our graph. Maybe I'll make this a little skinnier. Sorry. This section between here, this is my A part when he was walking home. This is my B section, right, where he's walking back to his friend's house to get his phone. This is when he walks halfway. He stops to talk to his friend, and then that last part he's running home, and that's why that line is a little bit steeper. So again, that section is A, this is B, here's C, here's D, and here's E, each section of that graph. So when you do these, I would label them right there on the graph, kind of like we did as we were doing it. So you're going to be labeling your sections. So down here in number 3, it says create a distance versus time graph showing Vanessa's distance from her house. Label each segment. So I'd like you to pause the video and go ahead and try to do the same thing that we're doing in number 2. Do the same thing in number 3. Read the descriptions. You have 4 different sections I should see in your graph, and make sure you label them A, B, C, and D. So pause it and try number 3. So checking your graph, again, our graphs might look a little different. That's okay, but the general pattern or trends that you see should be the same. So in part A, it says Vanessa left her house to run at a steady jogging pace, or we're jogging at a steady pace, straight line because it's steady. Vanessa increased her speed, but about halfway got a leg cramp. So here's where she has her increased speed. That's B, where she increased her speed, so it's a steeper line. Then in part C, it says she sat down and stopped to stretch. So that's where we have the flat part of our graph because she stopped and was not moving, not changing her distance. And then finally, she turned around and walked back home. So again, this is a slower pace, so maybe not as steep as some of the other parts of my line. So here's part D, where she walks all the way back to her house. So again, going uphill steeper, a flat portion of your line, and then a little bit flatter downhill line at the end. Again, they're all straight portions. Nothing's going to be curved there in that graph. Number 4, the graph below shows Justin's distance from his house as he walks to school. Interpret what you think happened in each segment of the graph. So what do we think happened? And this is where you get to be a little bit creative in your description, but you have to kind of look at the graph to figure this out. We can see that Justin left his house. Again, he's walking to school, right? And it's going up at a straight line. So for part A, I would say Justin left his home. Make sure you're writing this down. And walked at a steady pace. reason we're going to say steady pace is because that's going up as a straight line, right? That's a straight line. That's a steady pace. And he's going away from the house, increasing his distance away from home. Part B of the graph looks like it's flat. So for some reason, Justin wasn't moving. He wasn't walking. And this is where I said, like, oh, you can be a little bit creative if you want. We know for sure that for some reason, Justin stopped, right? He wasn't moving. I'm going to say Justin stopped to talk to some friends. Maybe you're going to say he stopped to, you know, pet a dog, or I don't know, like some other reason that he might have stopped on the way. I don't know. You can think of something. And then the last part of the graph, it is going uphill, but it's curved. It's an increasing rate or speed. So I'm going to say Justin started walking it again. Justin started walking again. And increased his speed. Well, I don't know, why would he increase his speed? Maybe so he wouldn't be late for school. And again, that's where I said you can be a little creative trying to figure out, well, why would he increase his speed, right? So again, notice the things that are important in what I wrote. Steady pace here because part A is a straight line. He stopped. This is a flat line. He started walking again and then increased his speed. Increasing your speed is where we get the curve in that graph, the curve in that line. So they're going to give you descriptions that you have to come up with the graph, or they might give you a graph and you have to write your descriptions. Again, our graphs might look a little bit different based on our starting points and how far we went up or down, but the general trend should be the same. Your descriptions should have some keywords or phrases in them, but they might also be a little bit different too based on your assumptions in the problem. So finally, we're going to turn over to page 32, and this is our homework for tonight, page 32, 1 through 11. Again, I know 1 through 11 seems like a lot, but this first part is pretty easy. You're matching each section of the graph, A, B, C, D, E, figuring out which piece of the graph matches. And then you're going to go back to that graph and then write in a description based on Grant and a hiking trail. And then finally, the last one, they give you a description and you have to come up with your graph. So it shouldn't take you too long. 1 through 11 is your homework for tonight. So go ahead and you can stop the video. And thank you for watching lesson 6, and stay safe and stay healthy. Thank you.